Hi guys, I just wanted to go over a problem on this 7A exercises with integration by parts because it's a little challenging. So feel free to copy this, work through this on this number 37 here. So 37 on the back side. By the way, I shortened this a little bit, deleted a few problems here, so just do up to 49. That's good. Plenty good. But let's look at 37. We're going to use integration by parts. So a review of integration by parts, if we integrate u dv, this is going to be uv minus v du, and actually the integral of v du. So the big idea here is we have some function of x, u, that we can't integrate, but we can take the derivative of. I know how to take the derivative of this, but I don't really know how to integrate it. So we can change it around, and then now we're going to try to integrate this other function. Okay, well, you have some experience with that now, I'm assuming, and so now we run into this kind of function here, all right? Now, we're going to run into a situation here where we've got this integral that we want to work with, and we're going to end up with something where we have our integration by parts. We do this first step, and then we still run into problems, so we're going to need to do integration by parts again here, and we'll end up with something that has some u's and v's here, all right, and then some u dv. All right, so we'll have some u's and v's. Let's just say we have some function here, some function of u and v. So a bunch of u's and v's, and then we end up with this. Well, if we get this, it seems like we just went in circles because we ended up with the integral of u dv again. But this is actually a good thing, because what this does for us is this will tell us we have integral of u dv equals some function, in other words, something with a bunch of x's in it, all right, some big mess, minus the integral of u dv. Now, if that happens, all we're going to do is we just add this over to here. Let's add that integral to both sides, and we can say 2 times the integral of u dv is equal to this crazy function, whatever it is. And then all we got to do to finish this off is divide. So if we divide by 2 or times a half on both sides, we end up with what we were looking for. U dv is a half of some, whatever that ugly mess is. All right? So that's the basic idea there. Okay? So we're going to be using integration by parts twice, and we're going to see the original expression pop out again. Okay? So watch for that to happen. All right, so let's jump into it. So we need to pick our u and our dv. Okay, so we want to figure out which one is u and which one is dv. Now the problem is here, integrating this is tricky. We can take the cosine of 2x, the derivative of that is no problem, but integrating it's tricky. We don't know how to integrate cosine 2x. We can integrate cosine of x, but not cosine 2x. So we'll let u be the cosine of 2x, and dv be e to the negative x dx. All right, see all the parts are there? Okay, u dv right there. Just mixed up a little bit, that's okay. So now we can go ahead and take the derivative here. Use the chain rule. Derivative of the inside is 2. Derivative of cosine is negative sine of 2x. All right, we use the chain rule there. And then we're going to integrate this here. All right, so we're going to integrate that, and we end up with v. And the only weirdness is we got -1 here, so we have to think about a little u substitution. Not this u, but a different u. So when we integrate this thing, we wish there was a -1 out here. There's not, so we'll have to put a -1. Okay, so work that out. This should be -e to the negative x dx. Nope, sorry, no dx. But there should be a dx down here. I missed that. Let's take care of that there. Should be a dx here. All right. So there's our first set of u's and v's, all right, for our integration by parts. So what we have is, let me copy this down, our integral of e to the negative x times the cosine of 2x dx is equal to, now the way we write this is kind of important. Now we're going to say uv, our u is cosine of 2x times v, which is -e to the negative x. We could put that in a different order, that's fine. But what's important here is that I have this is equal to, you'll see why in a minute, minus the integral of v du, so that would be -e to the negative x, du is this -2 cosine 2x, no, sorry, sine 2x dx. All right, and let's just clean that up a little bit, just kind of move things around. I might move this -e to the negative x in front just to make it a little prettier. Then we got all these negatives to deal with. Let's pull out this -2 and this -1, and that's going to be a +2 out in front, so the minus sign and a +2. And we have e to the negative x sine of 2x. And we say, what? That is not any nicer. So we've got to do some integration by parts here. Okay, so let's maybe come on over here and I'll set up another integration by parts. U, du, v, dv. All right, so u, again, we don't want to try to integrate sine of 2x. I don't want to choose that as dv because then I'd have to integrate it. So sine of 2x is going to be u. Sine of 2x. Okay. And then dv is going to be e to the negative x dx. That looks familiar. Okay. All the parts of that are there. Okay. So let's go ahead and let's work it out. Take the derivative of sine of 2x, and that's 2 cosine of 2x dx. And v, let's integrate this. So if we integrate both sides here, integrate that thing. We just did that already, right? So that's going to be -e to the negative x. There, that's it. All right. And so this is going to help us do this integral here that we're stuck on. All right, so let's do that. Now let's do this carefully. So I'm going to copy down this first expression, -e to the negative x cosine of 2x. Now we got this -2, and we're going to do this integral here. I think that's enough room. So we're going to do this by integration of parts. Okay. Watch out for this 2 times all of that. That's got to keep that straight. All right. And so we have uv, which is sine of 2x times v, which is negative e to the negative x, uv minus v, or the integral of v du. Gonna need a little more room on my parentheses. Okay. V, which is negative e to the negative x, du, which is 2 cosine of 2x dx. All right. We're getting there. Where are we getting? I don't know. It's getting messy, but that's okay. The reason why it's actually looking good is because this looks a whole lot like this. And that's a good thing. Okay, notice again, we've got a trailing equality. This equals this equals this equals this. All right? Again, this is a challenging one. That's why we're doing it together. All right? So, now, let's clean this up. Negative e to the negative x cosine of 2x. Okay, we're going to distribute this 2 out here. And so that's going to be actually a negative 2. Negative 2. This negative 2 times this negative is going to be a positive. Let's go to make that a positive 2. E to the negative x sine of 2x. All right, then let's pull out this 2 and this negative out here. This 2 and this negative out in front, which is going to be a positive 2. But then I'm going to distribute this negative 2 times this positive 2, which is going to make a negative 4. Times the integral of e to the negative x times cosine of 2x dx. And again, that's good news because we've got a match. This is equal to this. In fact, we've got 4 of them. See that? So our equation, looking at the far left and the far right side, this whole thing, let's add this 4 times the integral over to that side. And we're going to have 5 of those integrals. 5 of the integral of e to the negative x cosine of 2x dx equals, and then just going to clean this up a little bit. Let's factor out a e to the negative x. And just put I got a positive 2 sign and then a negative cosine. So let's just flip that around to make it a little nicer. 2 sine of 2x minus cosine of 2x. And remember, our goal here was to find this. So all we got to do is divide both sides by 5, and we got it. Or multiply by 1/5, whatever way you want to look at it. And so in the end, the integral of e to the negative x cosine of 2x dx is e to the negative x over 5 times this parentheses. That's it. Crazy, huh? So that's how we use integration by parts twice. Okay? And so now you have some experience. You've seen that it can be done. Don't expect that on a test or quiz. That would be a little cruel. We're not going to worry about that right now. All right? But that's the idea. All right.